Hey guys, this is my YouTube channel, and hereby I am going to give some details regarding the latch timing and STA. Here it is STA flow and some examples of the timing checks of the STA. So what you go to the important aspect of the STA. The main important aspect of STA is that the entire region is analyzed once. So when you go over the analysis of the inputs over the desired output, you go through the timing analysis only once. Suppose you give an input and it is going under through a clock domain. For example, you are giving a clock of 0 for a period of time, then you will go to the timing analysis with a particular purpose, with a particular period of time only once, and thereafter the required timing checks are performed for all possible paths. You are going through the all possible paths. Suppose this is the path going from the inputs from the various NAND and NOR, NOT, marks and other gates. The all possible paths are going through and our scenarios. So what is going through there? Up, down, latches, fluxes, flip-flops, etc. of the design. Why? The complete and exhaustive of all timing checks of a design. The complete and exhaustive of all timing checks of the design. So the reason is that the complete, the overall complete and exhaustive of all timing checks of a design is needed there. That's the reason we use the STA design flow for the timing checks, either the setup checks or the hold checks. When you go through the faster than all other methods, when you go through the dynamic timing analysis, it goes through various processes. You can't get it through a valued period for a valued clock. Suppose someone is going through 0, someone is going through 1, someone is going through the period of 0 to 100 nanoseconds and like such. But when you go through the static timing analysis, this is faster than all other methods and it goes only once. So when you look through it, you will get to handle that DI must be verified to be robust, which means that it can withstand the noise without affecting the rated performance of the design. The OCVs and PVTs can be modeled and handled by STA. So you should look through what is OCVs and PVTs, and it is modeled and handled by STA. When you go to the verifications, you go to the terminology, etc. That is all are handled through static timing analysis. So the reason to look after it, that you should go through the scenario. The scenario behind such is that the GLL and TML external environment C of a design, and it goes through the various inputs at least once and goes for the desired output. So what we get to know that the latch timing regarding the STA process for either buffer or inverter. When you are using buffer, it is as it is, the input is as it is, and for the inverter, it inverts the desired input. Suppose you are giving 0 as the input, it provides 1 as the output from the inverter. So it goes through that STA has various scenarios for the proper design. Why? It has a complete and exhaustive of all timing. It goes through once and completely, and has an exhaustive process. Exhaustive, it is a thorough process. When you start, it goes, suppose this is AND gate, this is ON gate, and it goes through the various processes and provide the desired output. This has an exhaustive process and help us to for a proper purpose. So what it is needed, that we need something that is exhaustive, that looks thorough, means goes once completely and provide the desired scenario with the desired path as the output. We are providing some design rule checks for that. The DRC is needed, that wire is connected or not, properly connected or not. DRCs. So what it is, that the buffer and inverter has a proper scenario and timing and all it is. The examples of timing checks is particularly for the setup checks or either for the hold checks. The head setup check is only needed for the setup timing, that is, as you know, as the flip flops from the rising edge to the means as triggered, and for the hold checks like latches for 0 and 1. So what is good has a continuous and proper basic analysis behind it, and that is regarding the physical design flow, that is work for it. Basically we used to go through the inputs. This is A as the input, this is B as the